Hello, everyone. Today, let's learn the second section of the sine-cosine tangent formula of two angles in one difference. Last lesson, we derived the cosine formula of the difference between two angles by using the rotational symmetry of the circle. Please write the cosine formula of the difference between two angles on the basis of reviewing the derivation process. Cos alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. This formula gives the relationship between the sine and cosine of any angle alpha, beta, and the cosine of its difference angle. In this lesson, we will use logic to derive the cosine formula of the sum of two angles, the sine formula and tangent formula of the sum and difference of two angles on the basis of this formula. We start from the cosine of the difference between two angles. Can you deduce the cosine formula of the sum of two angles? We first need to compare the cosine of the difference between the two angles with the remainder of the sum of the two angles. What are their similarities and differences? They are all cosine of angles, only in different forms. So, what is the relationship between alpha minus beta and alpha plus beta? On the one hand, we look at it from the perspective of computation. Convert addition to subtraction, that is, cosine alpha plus beta equals cosine alpha minus negative beta. On the other hand, from the perspective of substitution, we can replace beta in the cosine formula of the difference between two angles with negative beta. So, based on the above differences and connections, how to obtain the cosine formula of the sum of two angles from the cosine formula of the difference between two angles? Let's take a look at cosine alpha plus beta. It is equal to cosine alpha minus negative beta. Using the cosine formula of the angular difference, we obtain cosine alpha, cosine negative beta plus sine alpha, sine negative beta. Since we know that the cosine function is an even function, cosine negative beta equals cosine beta. The sine function is an odd function, so sine negative beta is equal to negative sine beta. Therefore, we obtain the cosine formula of the sum of two angles from the cosine formula of the difference between the two angles. Let's take a look again. Can you derive the sine of the difference between two angles represented by the sine and cosine of any angle alpha beta, as well as the sine formula of the sum of two angles, based on the cosine formula of the sum and difference of two angles? Similar to earlier, let's first compare the differences and similarities between cosine alpha minus beta and sine alpha minus beta. The angles they contain are the same, but the types of functions are different. So let's review what we have learned. Can the sine and cosine of an angle be connected? The induction formula we learned earlier, 5 or 6, can achieve the exchange between sine and cosine. Let's review together. What are induction formulas 5 and 6? Sine half pi minus alpha equal to cosine alpha. Cosine half pi minus alpha equals sine alpha. Sine half pi plus alpha equal to cosine alpha. Cosine half pi plus alpha equals to the negative sine alpha. Okay, based on the above differences and connections, how can we obtain the sine formula of the two angular differences from the cosine formula of the two angular differences? Let's take a look. Sine alpha minus beta. According to the induction formula 5 just now, it is equal to cosine half pi minus the difference between alpha and beta. Because we want to use the sine and cosine of any angle alpha beta to represent their approximate sine, I transformed this angle to obtain half pi minus alpha plus beta. At this point, we found that we can use the cosine formula of the sum of two angles to obtain the sine formula of the difference between two angles. We use the formula to open and obtain cosine half pi minus alpha, cosine beta minus sine half pi minus alpha, sine beta. According to the induction formula we just reviewed, we can obtain the difference between sine alpha cosine beta and cosine alpha sine beta. We obtained the sine formula for the difference between two angles using the cosine formula for the sum of two angles. According to the above problem-solving approach, can you directly write the sine formula for the sum of two angles? Looking back at our derivation process just now, we can write that sine alpha plus beta equals sine alpha cosine beta plus cosine alpha sine beta. Okay, let's continue. You can determine the relationship between the tangent function and the sine and cosine functions. Can we derive the tangent formula for the sum and difference of two angles expressed as the tangent of any angle alpha beta using the sine-cosine formula for the sum and difference of two angles? Let's first review how to use sine and cosine functions to represent tangent functions. We know that tangent alpha is equal to sine alpha divided by cosine alpha. Of course, in order to ensure that the tangent is meaningful, alpha is not equal to k pi plus half pi, and k belongs to z. So, can the tangent formula of the sum of two angles be obtained using the sine and cosine formulas of the sum of two angles? Based on the relationship between sine function, cosine function, and tangent function that we just reviewed, we can conclude that tangent alpha plus beta is equal to sine alpha plus beta divided by cosine alpha plus beta. So, according to the sine-cosine formula of the sum of two angles, sine alpha cosine beta plus cosine alpha sine beta divided by cosine alpha cosine beta minus sine alpha sine beta. But we hope to use the tangent of any angle alpha beta to express the tangent formula of the sum of two angles, so we still need to modify this formula. How to further convert it into the tangent of the sum of two angles represented by the tangent of any angle alpha beta? We convert by dividing both the numerator and denominator by cos alpha cosine beta, which means we divide both the numerator and denominator by cos alpha cos beta. Let's take a look at sin alpha cos beta divided by cos alpha cos beta to get tangent alpha. Similarly, the second term yields tangent beta. Below, we obtain 1 minus tangent alpha tangent beta, which gives us the sine and cosine formulas for the sum of two angles, and the tangent formula for the sum of two angles. How to use the tangent of any angle alpha beta to represent the difference between tangent alpha and beta. Based on our previous experience, it is easy to obtain that beta from alpha tangent alpha minus beta equals to tangent alpha minus tangent beta, which is greater than 1 plus tangent alpha tangent beta. Okay, let's review the idea we just deduced. We start from the cosine of the difference between two angles. From the perspective of computation or substitution, the cosine formula for the sum of two angles has been obtained. Similarly, we start with the cosine formula for the difference between two angles. The sine formula for the sum and difference of two angles was obtained using the induction formula 5 or 6. Of course, we derived the tangent formula for the sum and difference of two angles by using the sine and cosine formulas for the sum and difference of two angles. Because the sine, cosine, and tangent formulas for the sum of two angles provide the relationship between the trigonometric values of any angle alpha beta and the trigonometric values of its sum angle alpha plus beta. For the sake of convenience, we refer to these three formulas as the conformal formula. The sine, cosine, and tangent of similar angular differences are called difference angle formulas. So, please think about a question: how to use the sine formula of sum and difference of two angles to calculate the sine value of 75 degrees. Firstly, we need to consider which two to represent 75 degrees. We know the sum or difference of the special angles of sine and cosine values. On the one hand, if we consider that 75 degrees is equal to 45 degrees plus 30 degrees, we can use the sine formula of the sum of two angles to calculate the sine value of 75 degrees, that is, sin 75 degrees is equal to sin 45 degrees plus 30 degrees. Using the sine formula of the sum of two angles, we obtain that the sine of 75 degrees is the root 6 plus the root 2 divided by 4. What else can we do? We found that 75 degrees is equal to 120 degrees minus 45 degrees, so we can also use the sine formula of the two angle differences to obtain the sine value of 75 degrees. We see that sin 75 degrees is equal to sin 120 degrees minus 45 degrees. According to the sine formula for the difference between the two angles, it is equal to sin 120 degrees, cos 45 degrees minus cos 120 degrees, sin 45 degrees. Similarly, the root 6 plus root 2 divided by 4. Okay, let's take a look at example 3. Given that sin alpha is equal to negative 3/5, alpha is the angle of the fourth quadrant. Let's find three values: sine 1/4 of pi minus alpha, cosine 1/4 of pi plus alpha, and tangent 1/4 of pi minus alpha. Let's first take a look at the first value, sine 1/4 of pi minus alpha. What formula comes to mind when solving for the value of sin 1/4 of pi minus alpha based on the known conditions of the problem? We will think of the sine formula for the difference between two angles, where sine alpha minus beta equals sine alpha cosine beta minus cosine alpha sine beta. So when using the sine formula for the difference between two angles to solve this question, what are the two angles? The two angles are alpha and 1/4 of pi. Which trigonometric values of alpha and 1/4 pi are needed in the solving process? What values need to be further solved based on the known information? We know that we need to use the cosine and sine values of quarter pi, as well as the sine and cosine values of alpha. The cosine value of alpha needs to be further solved based on known conditions. Okay, let's take a look. Given that sine alpha is equal to -3/5, since alpha is the angle of the fourth quadrant, we obtain cosine alpha equal to 4/5 based on the same angle trigonometric relationship. Of course, to answer the third question, we also calculated the tangent alpha, which is equal to -3/4. With these preparations in place, we can now solve for the sine value of 1/4 of pi minus alpha. Sine 1/4 of pi minus alpha, obtain sine 1/4 of pi cosine alpha minus cosine 1/4 of pi sine alpha according to the sine formula of the two angle differences, substituted into the sine and cosine we just obtained, and the value is the 7/10 of root 2. So, if we remove the angle of alpha in the fourth quadrant given in the known conditions, what impact will it have on the solving process and results of the constraint conditions? Since sine alpha is equal to -3/5 and less than 0, alpha is the angle of the third or fourth quadrant. If this restriction is removed, we will have a classification discussion. When the angle alpha is the angle of the third quadrant, cosine alpha is equal to the negative value 4/5. At this point, the calculated result is the negative root 2 divided by 10. So, can we learn from the experience of the first question to solve the second and third questions? Based on the experience of the first question, we can easily obtain the value of cosine 1/4 of pi plus alpha from the cosine formula of the sum of two angles. Cosine 1/4 of pi plus alpha equals cosine 1/4 of pi cosine alpha minus sine 1/4 pi sine alpha. By substituting the value we just obtained, we can obtain the result as the root 2 of 7/10. We can also easily obtain the value of tangent 1/4 of pi minus alpha from the tangent formula of the difference between two angles. Tangent 1/4 of pi minus alpha is equal to tangent 1/4 of pi minus tangent alpha minus 1 plus tangent alpha plus tangent 1/4 of pi, which gives 1 minus tangent alpha over 1 plus tangent alpha, resulting in 7. From the above explanation process, we can see that under the conditions of this question, the sine 1/4 of pi minus alpha is equal to the cosine 1/4 of pi plus alpha. So, does this equation hold for any angle alpha? If established, can you provide proof? This calculation result is general. For any angle alpha, we know that the difference between sine 1/4 of pi minus alpha is equal to the sum of sine half pi minus 1/4 of pi plus alpha. So according to the induction formula we just reviewed, it is equal to cos 1/4 of pi plus alpha. Okay, let's move on to the fourth step, which is to use the formula for sum and difference angles to calculate the values in the following format. 1. Sine 72 degrees, cosine 42 degrees minus cosine 72 degrees, sine 42 degrees. 2. Cosine 20 degrees, cosine 70 degrees minus sine 20 degrees, sine 70 degrees. 3. Add tangent 15 degrees, subtract tangent 15 degrees from the previous one. Let's first take a look at the formula for sum difference angle, which converts the trigonometric function of alpha plus minus beta into the trigonometric function of alpha beta. And this question presents a trigonometric function of alpha beta, so how do we solve it? We can try using the formula from right to left to simplify the trigonometric function equation mentioned above. Let's take a look at the first question. Sine 72 degrees, cosine 42 degrees. Subtracting cosine 72 degrees, what angles are involved in sine 42 degrees in the equation? In the equation, we involve two angles, 72 degrees and 42 degrees, which formula can be associated with the form of the identical form. By observing the form of the equation, we can relate it to the sine formula for the angular difference between the two. Sine alpha minus beta is equal to sine alpha cosine beta minus cosine alpha sine beta. Sine 72 degrees, cosine 42 degrees minus cosine 72 degrees, sine 42 degrees. Well, based on the above analysis, we can conclude that the equation is equal to sine 72 degrees minus 42 degrees, which means sine 30 degrees equals 1/2. Based on the experience of the first question, can everyone independently solve the second question? We see that the second question also involves two angles, 20 degrees and 70 degrees. The cosine formula that can be linked to the sum of two angles. So we have cosine 20 degrees, cosine 70 degrees minus sine 20 degrees. Sine 70 degrees equals cosine 20 degrees plus 70 degrees, which equals cos 90 degrees, so we get 0. Let's move on to the next question. What formula can be used to determine the difference between adding tangent 15 degrees and subtracting tangent 15 degrees? Its form is similar to the tangent formula of the sum of two angles, where tangent alpha plus beta equals tangent alpha, and adding tangent beta equals 1 tangent alpha tangent beta, but it only involves an angle of 15 degrees. Let's review the solution process for the third question in example 3. When tangent subtracted alpha by 1/4 of pi, he also saw a similar equation. Everyone, can you be inspired by your solution? We can consider converting 1 to tangent 45 degrees in a timely manner, and then using the tangent formula of the sum of two angles to solve it. So we get 1 plus tangent 15 degrees minus tangent 15 degrees. We convert this one to tangent 45 degrees, so the molecule gets tangent 45 degrees plus tangent 15 degrees. We will retain the form of the formula for this one. Tangent 15 degrees, we write it as tangent 45 degrees multiplied by tangent 15 degrees. Based on the tangent formula of the sum of two angles, we obtain that tangent 45 degrees plus 15 degrees equals tangent 60 degrees, which equals √3. Okay, let's summarize this lesson. Can you accurately write these formulas? Let's first look at the cosine formula for the sum and difference of two angles. We express the cosine formula for sum and difference angles using the sine and cosine of any angle alpha beta. Everyone should pay attention to the symbols. We will write the sine formula for the sum and difference of two angles. Similarly, we use the sine-cosine formula for any angle alpha beta to express the sine formula for the sum and difference angle. Everyone should also pay attention to symbols. Let's take a look at the tangent formula of the third group and the difference angle. We have expressed the tangent formula of sum and difference angle using the tangent of alpha beta, and everyone should also pay attention to the symbols. Everyone should memorize formulas, master their functions and structures. When applying these formulas, it is important to observe carefully, compare and determine differences, and in the process of finding connections and ways to connect, understand the characteristics of trigonometric expressions. Understand the characteristics of trigonometric identity transformation, enhance the orderliness of thinking, gradually cultivate good thinking habits, and develop core competencies in mathematical operations. That's all for this class. Goodbye, everyone.